This December, NASA plans to launch a brand new telescope into space. This new telescope represents 2 decades of international cooperation, research, and development by the best scientists and engineers in the world. After years of setbacks and delays, the James Webb Space Telescope is finally prepared for launch. When it's deployed, it will be the most powerful space telescope ever built, capable of seeing farther into the cosmos than ever before. What exactly will the James Webb Space Telescope be able to see? And what are astronomers hoping to discover once it's operational? Well, let's find out. Like any spacecraft, the James Webb Space Telescope, or JWST, is an incredibly complicated piece of machinery. The entire 6.5 metric ton telescope is folded up tightly so that it can fit into the payload fairing of the Ariane 5 rocket that will launch it into space. This rocket will actually carry the telescope beyond Earth's orbit to a point nearly 1 million miles away, 4 times farther than the Moon. James Webb will be unfurled at Earth's second Lagrange points, or L2 for short, on the opposite side of the Earth from the Sun. At this point, the combined gravitational pull of the Sun and the Earth balances out the centrifugal aspects of the telescope's orbit, so that its position relative to the Earth will remain constant. This position at the L2 point is advantageous for a number of reasons. First, it keeps the James Webb Space Telescope in relatively close contact with Earth, but it is far enough away that the Earth itself isn't ever in the way of what James Webb is trying to observe. This gives it an advantage over the Hubble Space Telescope, which is in a 95-minute low Earth orbit. James Webb will also have less difficulty in tracking objects across the sky because its orbit is much slower. Another advantage of JWST's target position is that the Sun will always be on the same side of the spacecraft. The telescope is equipped with a wide shield to protect it from the glaring sunlight and allow for higher resolution images. But being so far from Earth also brings its disadvantages. When the Hubble Space Telescope was launched in 1990, the first images it sent back were unexpectedly blurry. The problem turned out to be a mistake. With its primary mirror, the shape was off by about 1/10,000th of an inch, 10 times thinner than a human hair. In 1993, the first service mission to Hubble was launched using the Space Shuttle Endeavour. Over the course of 11 days and 5 spacewalks, astronauts installed new equipment in order to correct the telescope's nearsightedness. The mission was a success, and Hubble began to return beautiful, sharp images of the distant cosmos. The primary mirror of the James Webb Space Telescope is nearly 3 times as wide as Hubble's, promising higher magnification and better resolution. But if there's something wrong with JWST's mirror, there will be no way for astronauts to fix it. 20 years and $8.8 billion will have been for nothing. The engineers and scientists are also counting on James Webb being able to deploy properly. Even if it arrives at the target Lagrange point with no problem, the sunshade and even the mirror itself will still need to unfold themselves. If any component fails to correctly deploy, or if the fragile sunshade tears, the telescope won't be able to work with no hope for repair. But there's a reason that these space agencies are willing to risk so much with the James Webb Space Telescope. If all goes according to plan, and billions of dollars have been spent to make sure that it does, it will be more capable than any telescope in history. James Webb has the largest primary mirror of any space telescope before it, with 25 square meters of light collecting area. But its mirror isn't actually a single mirror at all, but a tessellated pattern of 18 smaller hexagonal mirrors. For one, this allows the mirror to be folded into 3 separate pieces so that it will actually fit inside the rocket. Second, these mirrors are connected to a series of highly precise micromotors which can individually adjust the orientation of each one. This is called an adaptive optic system, which is used to fine-tune the telescope's focus and filter out any errors and aberrations in the final images. The James Webb Space Telescope is also equipped with a set of extremely sensitive infrared detectors capable of seeing into the near and mid-infrared spectra. Cosmic clouds of gas and dust normally obscure wavelengths of visible light, but JWST will be able to use its infrared eyes to peer past the dust and see what is hidden beneath. Cosmological redshift also causes the most distant objects in the universe to appear faint with their spectra. Stretched to longer wavelengths using infrared light, JWST will be able to see farther than ever before by picking up the dim red-shifted signatures from these distant galaxies. Infrared space observatories have been notoriously difficult in the past because they are required to operate at very low temperatures. Otherwise, infrared emissions from the spacecraft itself will overwhelm the sensors and render the telescope blind previous telescopes such as the Spitzer. Space telescopes have relied on fluid coolants, but it is usually exhausted in only a few months or years, severely limiting observation time. But James Webb doesn't use any coolant, so it won't have any of the same weaknesses. Instead, it will constantly keep below 50 Kelvin around minus 370 degrees Fahrenheit or minus 220 degrees Celsius by relying on its sun shield and a system of thermal radiators. Armed with its adaptive primary mirror and its powerful infrared sensors, the James Webb Space Telescope is hoping to answer some very big, unanswered questions about the universe. Over the past few decades, astronomers have racked up a list of nearly 5,000 confirmed extrasolar planets, planets that orbit stars other than our own sun. But given the vast distances between us and these alien worlds, it is difficult to resolve any details besides some rough estimates of their sizes and orbits. JWST is meant to find out much more. Its infrared scopes are designed to study the way that their stars' light interacts with their atmospheres. This way it can determine what gases are present in an exoplanet's atmosphere. James Webb will search specifically for water vapor, oxygen, carbon dioxide, and methane, potential signs of life. Will the James Webb Space Telescope someday be able to help us get one step closer to contacting ET? Only time will tell, but in the meantime, the wealth of information that the telescope will provide on our galactic neighbors will surely prove invaluable to the scientific community. While James Webb isn't looking for new planets to explore, it will have its sights set on the darkest, most remote corners of the universe. The speed of light is incomprehensibly fast, around 300,000 kilometers per second. But light still travels at a finite speed, so it takes time for it to get anywhere. 8 minutes to the sun, 4 years to the next nearest star, and more than 100,000 years to cross the Milky Way galaxy. It can take millions or billions of years for the light from other galaxies to reach us because they are so far away. By looking farther and farther into space, we are effectively looking farther back in time. When you look up to the sky at night, you don't see stars and galaxies as they are, but as they were however long ago that light was emitted. JWST will be able to look farther back into the history of our universe than ever, perhaps as far back as the Big Bang nearly 14 billion years ago. There are still a lot of mysteries surrounding the dark era, when the very first stars and galaxies were beginning to fall. By studying the very oldest galaxies, James Webb could help us understand the large-scale structure of the universe and how it changes and evolves over time. It may also shed some light on the enigma of dark matter and offer some insight into the formation of primordial black holes. The James Webb Space Telescope has been a massive undertaking, one that has involved tens of millions of man-hours of hard work, billions of dollars, and the cooperation between 15 countries around the world. It is a technological marvel in and of itself, and it's nearly certain that the telescope will help make many profound discoveries in the years to come. One of the first big events that the James Webb Telescope will be looking at is a star explosion so big you'll be able to see it from Earth with the naked eye. If you want to know more about this once-in-a-lifetime event, make sure to click the video on your screen, and I'll see you there.